going to be folks in the room that's going to know a lot more about what I'm talking about than I do, unfortunately. So I'm going to need help from the group. And Kate, we thank Kate for producing these slides and the notes and taking her time over the break to do this. So we were charged with the long-term issues in setting up an ESM and AOGCM runs and scenarios for the fifth assessment. What we kind of settled on was the idea, again, we had talked about before, this core activity or common activity and then research, and we're focused only on the common and our core activity. And so for the core model to be used, we were thinking of a model that had a simplified terrestrial carbon cycle a terrestrial carbon cycle with land use and succession. No succession, right?
Biogeography.
Biogeography was the word. And simple ocean biology on the ocean side. So just to close the carbon loop on both sides is the idea. For the non-ESMs, for the AOGCMs, and if there's any emix that would participate in the thing, it's the same way as in the AR4. That's what we meant by business as usual. And our charge is the long-term issues, so 2100 and beyond. We consider to 2300.
So what do you mean by business as usual? I mean, like just
that's what I just said. They're going to be run the same way that they were run in AR4. Concentrations. We'll get there.
Okay.
They're reinforced by concentrations in land use data.
Well, I would say some of the emix, have at least some versions of a lot of the things.
If they have them, they can run them, obviously. But if they don't, okay, let's see. Long-term issues. And we're thinking of defining some set of benchmark scenarios. So we combined, in our discussion, we tried to separate out the first and the third questions and talking about them separately, and we were unsuccessful. So we just combined them. So what are the important questions to be answered, and then what are the emission scenarios appropriate, got combined almost also along with the experimental design. So recently, there was these scenarios that Mackie talked about, a kind of a low stabilization, a medium, and a high stabilization scenario. So we thought that we would have defined two scenarios to drive the models. One was a low radiative forcing using the gridded land use data. And an example would be something like a B1 with a mitigation. Is that the right terminology? Okay.
It leads to stabilization.
Right. So this would be a stabilization scenario. And is that a 3 watt?
Well, there is a 3 watt version and 4.5, I think.
Okay.
Both are possible. But in the group, we discussed the 3 watt as being an extreme low one.
Extreme low one. And then we would also recommend using a high radiative forcing one, again with the gridded land use. And it would assume a low capacity for adaptation. And it would be something like an A2 or an A1 FI.
Well, the adaptation is somewhat independent of the scenario.
Well, but it's not independent of the drivers of the scenario.
No, but you could have equivalent scenarios that have similar drivers. I mean, especially on the high end, you could have high emission scenarios with high capabilities for adaptation and high with low.
Well, that's why he has A2 and A1 as a possible examples.
We were trying to capture the absolute low bounds and high bounds, the extremes.
Right. And it'll become more clear. There's actually proposal that if you step back, our idea is where, in a sense, working group 3 would present a set of benchmark scenarios, or these two scenarios to be used in the coupled runs, or the ESMs. And then the ESMs would, after their run, would give back to the working group 3 community what the models what the models did with those, and so it'd be fluxes from the land and the ocean of carbon.
Yeah. I want to add something else in response to Steve, and that is that these two benchmarks would belong probably to ensembles in the working group 3. So the type of questions that he's asking could be answered.
Right.
But only two trajectories would be then delivered to the model.
Right. And so then after the working group 1 models would be run, the working group 3 would develop sets of emission scenarios that would fit these two consistent. Right.
So the idea would be that this B1 would be like you have, that's the mitigation pathway, right. And A2 would be no mitigation.
Right.
Yes.
Yeah. Okay.
So the proposal is, and I wish Peter was here. It was Peter Cox's idea. It was something I had never heard of before. It was a different way of thinking about driving an ESM. And instead of driving the ESMs with emissions, the idea is to drive them with concentrations. And that's something different, at least from I hadn't heard anybody talking about that before. And I'm going to go over here to this graph, because this is what he used, and see if I can work my way around this graph the way he did and answer your questions.
Start with working group 3. The handoff.
Well, I didn't understand this part down here very well, so I wasn't going to start there. But the idea is that working group 3...
I understood that part. Those
okay.
Those were the two stylized scenarios.
Okay, right.
The two benchmarks.
Okay, so this working group 3 would give working group 1 community a time series of the greenhouse gases and the land use and the things that we need to drive the models, ESMs. And so you could think of if you use the CO2 as an example, you have a CO2 concentration starting from present day, going up to some value and then stabilizing in the B1 case, and in the A2 case it would just go up and stop, I guess, with time. And that's how we would drive the ESMs, with those concentrations. Doing okay so far?
That's the easiest step.
Okay, good. I'm gonna fail after this. So in the ESM then, what the land vegetation is seeing the CO2 concentration that's being given. The ocean, as it's computing its fluxes in and out, is for carbon, are also seeing these emissions, and radiatively, the model is using these to compute its radiative forcing.
So can I ask, is the land or biogeochemical model producing fluxes of CO2,
absolutely,
but they're being thrown away?
They're not just being archived.
Right, okay.
Archived would be the word I would use. So that's the idea, is then these archived land and ocean CO2 fluxes would then be given back to the working group 3 community for them to evaluate. There's a number of things they can do with those fluxes. One is they could actually evaluate the models that they initially used to give us these concentration scenarios and see how consistent the two are. Another thing can be done.
One step here.
Well, it's probably more than one.
You've got the natural fluxes here.
Yeah.
You've got the delta CO2 in the atmosphere. Just by the residual will be the anthropogenic emissions, which you can diagnose here.
Yes, we're getting to there. That was the next thing I was getting to. But that's a good. You got there. So from these, you can diagnose the anthropogenic fluxes, and working group 3 can also develop their new emission scenarios, and then an important.
So can I make sure I understand? Is the anthropogenic fluxes are the tendencies that are produced by this nudging, essentially, or
that's not nudging. We're imposing these.
Well, okay. What is this?
Forget this. This was a proposal that was up in.
Okay, and then so
this isn't.
It's the difference between the fluxes predicted by the carbon model and the ones which.
Well, if you know this curve and you know these fluxes, then you can compute that.
So
basically, if the model that produced the original scenario had a carbon cycle that exactly mimicked the GCM, there would be complete consistency.
Yep.
Yeah.
Now, as it turns out, if you do this in multiple GCMs, even if it was consistent in one, it's not going to be consistent with the others.
Right.
So then you get to analyze the effect of these uncertainties and so on and so
So
forth.
you get a band, Steve. The way
Yeah.
I see
Yeah,
it,
You would get
you get a band back. So the new revisions in working group
Right.
3 models should stay within the band if possible.
Well, I mean, you know, it's you do a lot of things with it.
Right. So that's the basic idea. This is how we're envisioning the models being driven, both the historical and the future.
And Ron, the main advantage of doing that rather than just doing emissions is that more models can do these scenarios. Is that the main?
There's a bunch of advantages to this idea. One that is obvious is that non-ESMs can use this same scheme and participate in the IPCC. So that's one. And then you're going to have to help me on the others.
Well, I think from the point of view of timing, the idea would be to shorten the full cycle that would be required if we would follow the traditional way, which is their emission scenarios, their climate runs, their impacts and adaptation studies, then they feed back into possibly emission scenarios. And so far that loop has never been closed. This kind of different loop would give the advantage of starting with 2 stylized benchmark type of scenarios, and through the climate models providing feedback to the integrated assessment models, just to see how realistic the climate part is and what does that imply for the emission pathway. So I think this shortens the process but gives the feedback to the working group 3 that's required.
Now, another advantage is that the different ESMs are being forced with the same radiated forcing.
Exactly.
Controlling
Yes.
for that.
Yep.
So you have a more direct comparison of the climate changes.
So
There are
when
some
you,
downsides.
when you get those fluxes back and you compare that with what was originally prescribed,
Mhm.
and therefore you know the anthropogenic component, and work group 3 now has what anthropogenic component would close this loop. Do you then compare that anthropogenic component with what you were assuming when you provided that initial
Yeah.
Yes.
in the first place? And what if it doesn't match?
Then you change your. Well, then
Then
you
you
have
go
to
through
usually
this-
have to iterate at least within
Okay,
our
so
own
you go
model.
through the loop again.
Yeah.
Well,
No. You don't
No,
have to do
no, you don't go through the loop.
you would you would. Well, actually, it depends on your time scales.
Oh, no, you go
You
to
could-
the loop in the
you could do it-
AR11 or something.
Right, you could do one loop with any possibly emix if you wanted to do it quicker, where the emix are tuned in some way to mimic the AOGCM responses. Another way to think about it is the next loop is the next IPCC.
And I mean, I'll show a graph on this maybe on Saturday because it's of interest. But you know, we do this now where you change the carbon cycle assumptions and then you see what the anthropogenic emissions consequences are, and so it's exactly the same thing. It's just that you know you can choose to constrain it within the range of the GCMs, or actually you can go. The other thing you can do with this is you can compare that range with the range from the EMIX, because what those models do is they do explore a wide range of carbon cycle uncertainties, and you know that's part of the system. You can say, well, are the GCMs spanning that whole range, or are they spanning a part of it? And you'd find out, and that would be useful information.
Okay, so this is one of those important things. If you got it now, we're going to move on. So a second run that we're proposing to do with the ESMs in order to evaluate the carbon cycle response in the model is to do this same loop. Basically do everything that's in this loop except that you don't let the prescribed CO2 time series impact the radiative forcing of the model. So that you allow this increased CO2 to impact the ocean biology, the land biology, but not the radiative forcing. So the climate will only slowly, it'll be a present day stabilization scenario for as far as the physical climate model is concerned. Okay, I'm just looking at Jerry, see if he understands this. I was glazed eyes for a long time also.
I kind of thought what you just said was what you were talking about on the first loop.
Now the first loop through, you let, this is our norm, the first loop through is a normal projection of future climate change as far as the physical climate model is concerned.
Concentrations. You're just
With
keeping track of
concentrations.
what the deficits or surpluses are.
It's what we've always
Yeah.
done. It's just that it's got a carbon cycle attached to it that's
You don't-
not impacting the radiative forcing.
Right. So whatever the carbon cycle is doing, it doesn't affect anything that's going on in the atmosphere. You're saving.
Not the radiative forcing. Be
Yeah,
careful what you're
right.
saying.
Well, I mean,
But does it
if you
change
have-
the state of the atmosphere, or the state of the Earth system, or just, well, other than the carbon?
No, it could change the land. I mean, if you had your land, your vegetation would be changing. You would be changing albedos and changing the roughness.
Okay.
So the point is to break apart what the CO2 radiative forcing, the climate change component from the CO2 radiative forcing is, from what the CO2 impacts on the land surface is.
In the second round, exactly.
And the ocean.
And the ocean also. No,
I'm quite confused.
that's easy. I can understand that.
Supposing you do have a carbon cycle,
Yes.
which means that you're predicting, say, CO2.
Yes, you're not going to
Okay,
actually
so-
use that
So
predicted
you're
CO2.
specifying the CO2 for radiative purposes and for,
You're not going to use that predicted CO2 for anything.
except
Well-
to deduce fluxes.
No.
Well, you're not really
Yeah.
predicting the
Yeah.
You have
CO2.
to have to use it to deduce fluxes.
No.
No.
No. You use the specified CO2 to compute all your fluxes.
You're not actually predicting the CO2 because you're missing one component. To predict the CO2, you need to input fossil emissions. So in this first experiment, you're not inputting the fossil emissions,
But
you're
that's what I
prescribing.
thought that restoring term looked like.
There's no
Forget
restoring term.
there's
Forget
no
the
restoring
restoring
term.
term. That's out.
Ignore that.
That was Plan B.
Okay.
That was
That's
that got voted down. And that's why that was going to produce this curve here, and I didn't like that
Well,
curve
it's
at
a
all.
climate change. It's a future climate change projection. So you've
You're,
got
but you're stating what the CO2
Exactly.
is. You're not
Exactly.
predicting it.
exactly.
Exactly.
So you don't have a prognostic equation for
For
CO2.
CO2. That's correct.
But
The prognostic equation for CO2 is in working group 3. It's not in working group 1.
They're using a different model from you.
Yes.
Yeah, and
And
then
there you
I
have
mean,
it.
in principle, if you did that up on the upper right-hand side, you've got a certain number of problems associated with it, but you could deduce the CO2 fluxes that are consistent with what you put in for the CO2.
well, that's eventually what you do too.
That's eventually.
Yeah, but you're not going to do it with the same model.
Well, well, there's also nobody's doing it with the same model,
No,
so
but
that's the
we-
whole point. They'll now be
Okay, but
comparable.
back up a minute. I hope I'm not being tedious, but supposing you did that, you could then go back and say, now I've got some CO2 fluxes.
The
Let
problem-
me turn those on.
The
and see
problem
if I
with
get
this
back
guy,
to the same
the
answer.
problem with this is that you could get a long way. It's very easy in an ESM, especially in these first generation ones, to get, I think, a long way from what this input is. You could literally do what this is doing over here. And you could be, if that's impacting the radiation, there could be all sorts of,
And that's not just an
No, you don't have to
ESM.
let it impact the radiation. You can let it impact nothing but the prognosis.
Well,
CO2 itself.
Not just in, even in a simple model, that's essentially a carbon cycle inversion, and that's very sensitive to initial conditions, and it's extremely.
and your
that's-
spring constant that's underneath and all sorts of things. So that's why we talked about it and said no.
So how do you decide whether the carbon cycle has a positive feedback, or how big the feedback is from the carbon cycle?
By looking at these,
No, we did another simulation to do that.
Oh,
We did another simulation when the radiation doesn't see the prescribed.
Well, you get to look at the fluxes too.
At the fluxes.
The fluxes from the land.
the fluxes of the two loops when you go around twice.
Because the land fluxes, you can, depending on what you save, what's regrowth, what's land use change, and so on. So you can diagnose from that quite a bit about what's going on.
You still need
climate feedback, you need that additional simulation.
You need an additional simulation if you want to look at
The
it.
one that's
Climate
Well,
change.
listen, this is part of our proposal. This is actually, so for the proposal, if you think about AR4, we had 3 future scenarios. This one we're only having 2, but we're actually for the ESMs they're going to make 2 runs of each, so that'd be 4.
So this is, there's a simpler way to do part of the climate feedback, and that you can run both the components uncoupled and you just see, you change the climate, you change CO2, and you see how the systems respond. And then what this adds, and that's much cheaper, obviously, of course. And then what this adds is you get the interactive feedback between whatever albedo, it's still a partial solution, because the albedo feedback and vegetation water feedbacks are going to change climate and they'll interact with the vegetation. But you don't get the full climate change. You're going to get like a little bit of climate change from whatever the land surface is doing. So it's still not a perfect simulation, but it does tell you something that you can't diagnose purely from that one, although you can diagnose a lot because your equations are telling you, how much the plants are responding to CO2 and so on.
It's not only CO2, it's
Everything else, yeah.
Temperature.
It's-
So you need that additional.
Yeah, so I think I see this now, because basically your first set of two experiments tell you what the forced response is, just specifying concentrations. You save, presumably, the extra CO2 that's going to be coming out of the system. Then you add that back into those concentrations, do another set of runs to figure out what the additional part from the carbon cycle was.
Actually, the simple
No.
models can
No.
do some of that.
No.
Could do it
No.
like that.
Well,
So
what
what's
we
the
really-
second set of experiments?
One has
The second one is everything. It's exactly the same as the first. You just don't let this CO2 impact the radiation.
But why do you do the full run? Why don't you just take the climate change? I mean, okay, so you want to know carbon feedbacks without climate change. So why don't you just run the model with, fixed climate and, let that run to equilibrium? You just do a cycle and without. I mean, you could decouple the models
You could
and
do
diagnose
this.
those.
You could do this run a couple different ways, but and you're right.
Because
I thought
now
of
you're getting
running.
a little bit of climate feedback, so you're getting some, but not all of it.
We talked about that, and the thought was that this way was in a sense easier because it's just a rerun of the model, whereas control runs drift also.
Yeah.
And the drift in control runs isn't much different than the drift in a stabilization scenario. So in some models they could be quite a bit different. So it really, which is better or worse depends on the model. So this seemed as straightforward to describe as any, just do the same run over again. But you're right, there is a little bit of climate change in this run.
I still wonder about the very first one, because think of it this way. These guys have put together, let's take the high radiative forcing rule. They say, oh, this is our best guess at what the anthropogenic component will be like. And then you end up with that curve that you give the atmospheric model. And then you end up giving back to working group 3 what the anthropogenic component really was, and it turns out they were wrong. So what you've ended up doing is you've had your ESM spend all its energy on something that was wrong.
Well,
it was a curve that was produced making one assumption.
Except that's not likely to happen in the sense that your model may say we were high, your model may say we were low, your model will say something else. So, you're not going to get one answer to that question.
You don't know that. It could be that all of them tell you you're wrong in the
Actually,
same direction.
well, we will know that as long as we're collaborating, from between them. I mean, if we come out with every Earth system model having a carbon cycle that is dramatically different from what's in integrated assessment models, I mean, that means we haven't been talking for the next 3 years. And hopefully that won't happen.
But isn't the idea though that maybe it's not true, but isn't the idea that if you applied these corrected anthropogenic emissions, then you would have gotten the stabilization.
Right, but they will be different. The thing is, they will be different corrected emissions for every ESM.
Yeah.
So that means it's you've got.
And that basically says that every ESM needs a different scenario for stabilization.
Right. So this has the advantage of you're comparing the result of the same climate forcing, which I think is a significant advantage, particularly since non-ESMs or partial ESMs, they're all playing on the same footing at least. For IPCC, I think for other comparisons, you would want to do
it differently. I also said that in our discussion that it's conceivable if you did a C4 MIP2 that you would do it differently in that you may drive those models with emissions rather than concentrations. But for the IPCC, in some sense, this is a safer route to go for the first go around in their system models. it's safe. Yeah.
I think it's just a lot cheaper to inverse calculate in an IAM, integrated assessment model, than it is in a climate model. You get one sort of basic climate model run, then you fix the IAM.
From a working group 3 perspective, I absolutely agree with you.
And then you have a consistent set of emissions and climate models, and off you go.
Yep.
And then you can feed the impacts guys to the lines.
Actually, in some sense, there's no plan B for this, because working group 3 won't have enough time between now and when we want to run the models to develop the emission scenarios anyway.
Absolutely.
This is the only real way that's going to work.
So then you can go off and run.
It's a practical solution.
Three can go off and create new social economic scenarios.
But it's actually a very good solution to me as a working group 1 person, because it allows one less feedback to be operating in this whole mess to kind of constrain the models.
But then when we do come back with new social economic scenarios that have different emissions trajectories, we're not going to run through the climate models.
They are
We're going to run through simple models.
Simpler models. And then AR6 might be a different experimental design than this one. I think this is an AR5.
Special.
Maybe 6, who knows how it works, but it's certainly a 5. At some point you probably would want to change it, where you start integrating the integrated models into the AOGCMs and do the whole mess at once. Whenever that happens. Ready to move on? Yeah, that was the hard part, I think. We hope. So, one of the things that we thought was important was to allow a comparison between the AR5 models and the AR4 models and the TAR models. And this prescription over here allows that pretty straightforward, especially if we use the A2, since the A2 was in both AR4 and the TAR.
Did you use everything from A2? Because everybody always complains about the methane in A2.
Cue the folks in the back row.
I think that the working group 3 scenarios would have all gases
And
to
they
start
wouldn't-
with, but
they
then
wouldn't
you
be-
translate them to concentrations.
Yeah, it wouldn't be SRES emissions. These would be revised,
Yeah, they're-
updated versions.
Yeah, because the
Regardless.
revised set already exists. They would be slightly different.
And there'll
So
be
they
more.
wouldn't be directly comparable.
They wouldn't be
except
direct-
if it's
okay.
somewhat different.
Right. And,
Yeah.
they'll be revised next year again, right?
Yeah, I mean,
uh,
that's just the communities moving forward,
Right.
just like the climate
Okay,
models.
so they're not
these models
exactly the
are being
same.
revised.
They're close.
Well, as you pointed out, the sulfur emissions are down.
Are
That'll
They're
make
way
it
down.
better.
Yeah, the aerosols will be a lot less. An interesting question that has to do with the biofuels, and when you get these fluxes out, and for the B1, you can ask yourself a lot of interesting questions that has to do with land use, and if you're going to farm every bit of land that you can to get energy.
Well, and this actually gets to, the way you would deal with that question is to take, GCM output and then run that through an ag model, to start to look at the variability, which really gets the meta question here is, saving the right data needed for impacts.
That's our
Last slide.
Okay.
that's our last slide.
We thought of that.
What a great idea.
And so this question has to do with the time scale that we're thinking of. And so we're thinking of an experimental design that runs from present day out, or actually historic, pre-industrial through present day to 2300. And the B1, like the low emission scenario, stabilizes 150 years out from present day, something like that. So one interesting question is, once that stabilizes, how long does it actually take for the concentrations to stabilize? And you could get at that by looking at your fluxes, these fluxes. And then, also an interesting question is the physical climate side of things, how the stabilization like we did in AR4. Yes?
Was stabilization run out to 2300?
22 or 2300. Some models went to 23, some went to 22. It was optional to go to 23.
So really the only difference here is effectively vegetation and perhaps ocean geochemistry. And those are the two types of going.
Will be active.
Yeah. So, but does that change that result?
Well, no, but you can look at those fluxes and see if you're actually getting stabilization in the model.
Well,
or not.
You're prescribing stabilization.
You're getting it from obviously the CO2 time series you're getting, but the question is, does the model think it's stabilized or not?
Well, the fluxes, I mean, you have to adjust. I mean, you have to adjust the anthropogenic emissions to track, the declining uptake. I mean, that's something we already know. So there's no, fluxes never stabilize. They're always, they're approaching and asymptotically approaching some equilibrium.
And that's the question: is what's that time scale?
Like?
Right. Let's see. I've been up here too long.
So we just jumped to question 5.
Okay.
Because we've done 1, 3, kind of 2, and
4.
4.
This is one the question has to do with ensembles and numbers of ensembles. And we just noted in passing that for the historical forcings, the detection attribution community wants lots of ensembles. And they actually want lots of ensembles with just subsets of the forcings also. And that was the same in AR4, and that's not going to change in AR5. For the future, it was thought that the carbon cycle, adding in the carbon cycle in these models, doesn't change the need for the number of ensemble members. And I think for the future runs, the number of ensemble members vary from exactly 1 to 8. And I think there were some groups that ran 1, some 3, some 5, and 1 8. So those kind of decisions were made somehow inside the groups of deeming what's important, and the addition of the carbon cycle is not going to change the rationale for those numbers. So we punted on what's a good number.
I mean, there's a question, a science question of do adding these components change the variability between ensembles, and that's it doesn't take a 300-year run to figure it out, perhaps, but that's groups individually would probably.
There's questions that one could ask with those kinds of ensembles of the future runs or not.
So Ron, what if you're having this trouble with the Amazon, and what if some of your runs, produce an Amazon, and some of your runs?
No, the Amazon problem is in the control run. It's before you ever get into this.
What if you had a problem?
See.
But if you had a problem if you had a situation like that going forward, then that wouldn't be true, right? That a small number of ensembles would be
it depends if you know you have it or not.
Yeah.
If you don't run them, you'll never know you have that.
Well, I guess there's the point there that, in a sense, if one of these additional components adds more variability, you might need more ensembles to test that. And that maybe only in 1 of 10 times or 5 times, the Amazon deforests, or 1 in 10 times it doesn't. I mean, that's if there's enough nonlinearity. And that's something we'll just have to see.
That's a research question.
Yeah.
But you're really interested in big space scale, global, long term. And that's kind of what you're.
That's
you're
the
getting
core.
At with these. Yeah.
So for the initial conditions and how they initialize these models, it's a schemes that are similar to what was used in AR4. And what was used in AR4 was you develop your model typically around present day, and you just put the radiative forcing to sometime in the 1800s, and you fix it at that. You let the model equilibrate to that kind of in a quasi sense by running several centuries, and you just declare one day as the start of your control run, and you start running your control, and then you start your historical run off that control. And for ensemble members, you just pick different dates along that control, just what we've been doing.
And that is the carbon cycle.
Yes. And one evaluation that's going to be new is, okay, you're running a control, pre-industrial in quotes, since it's not really pre-industrial if it's 1850. But an evaluation criteria that is going to be used in the IPCC, no doubt, is going to be, well, how stable is the PCO2 in that control run. And folks were coming up with values that were defined as good enough. And so one was something like 10% that your drifts in the PCO2 in that control run were 10% of the 1990 emissions.
Over what period of time?
That's a good question. Per year, yeah. Or some long-term average. I mean, since
per year is huge.
Is that per year?
no, you have emissions. 1990 emissions gives you so much value, right? And so if your drift in any one, if say you make a 300-year control run, and you have a trend, that trend line is going to be, you know, so much per year. You can look at that and compare it to the 1990, and it should be 10% of it. Does that make sense?
I think he meant by 0.4 petagram is 0.2 ppm. So I would assume that refers that's per year.
Okay.
Worth checking.
Okay.
Well, the more important thing is not that there's what these numbers are at this point to me. The more important thing is to communicate to the modeling groups that there's going to be an evaluation of this, and that it's something that they should pay attention to as they're developing the models. What the numbers are needs to be communicated also, but we're about 3 years from where we have to know what those numbers are.
Although, yeah, I just have to think about that, because in a sense, you would evaluating a drift from, you know, a stable 1850 state is in a sense easier, because, you know, you don't have the imbalance in the carbon cycle that you have today. So if you start with a steady, I mean, in a sense, that would be an easier one to evaluate.
Yeah.
Which maybe, so that's, is that what you mean?
Yeah.
So, but you have 19 emissions, so I was confused. But if
No,
you,
it's how big a drift is too big.
I see. Okay, 10% of.
Okay. And this isn't talking about development, which has other issues of having to do multiple long runs to stabilize the carbon cycle.
This is
just the experiment.
It's an evaluation of the degree of how these fluxes between the land and the ocean are behaving in a balanced way.
But you're assuming the
when the
development's
climate's balanced.
The development's already occurred.
That's
It's got
right.
a relatively stable carbon cycle.
That's what it's trying to just evaluate the overall, but in some sense, fidelity of the whole model. It's a holistic way of looking at it. So last but not least is data issues. In the last IPCC, the variable lists for the 4 components, the atmosphere, the ocean, the land, and the sea ice, were made up pretty much ad hoc by a very small group of people at the last minute. As it turns out, the atmosphere list is probably the one that was made most people the happiest, at least in working group 1, because there had already been an active atmospheric model intercomparison project. The second best one, I think, is probably the land, because there had been an active land model intercomparison project also. The ocean and the sea ice ones were probably hurting the most. And there's been attempts at trying to involve various of the right WCRP committees to look at what those lists are. In a similar fashion, there's going to have to be a group of people that are involved in carbon that make up a carbon variable list to be archived. That's agreed on, and that should be done soon, not too, soon being in the next year or so.
Carbon, aerosol, ozone, whatever.
Anything that you want to look at in a common way.
There's already a little bit of a start on that, but I'm sure you guys have too. This minor in comparison of the logic after working with the CCSN is put together the first draft of that document. They're iterating on that list of variables and diagnostics.
Right. There's also such a list from C4MIP that would exist.
That's when they started.
The important point that Richard made is that working group 2 and 3 which were more or less completely left out of the last iteration, need to be very active participants in this iteration, because for no other reason, we're going to be handing these things back off to them. And sure, it'd be good if we do it in a way that they could get them. And that's the whole point of the exercise, right?
Yeah, and there's this, because it's not just the aggregate fluxes. There's a lot of things that would be extremely useful for us to diagnose our model. So exactly.
And and again, there's going to be a whole list of those things, and so I think that's what this middle part says. And then, as a corollary to that, once the data is archived and you start trying to disseminate to users, the different communities have different requirements on how that data is stored and then distributed. Most Working Group 1 folks like it in a field type format where you have one field and then for 1 month and then stored like that. Whereas my impression is for a lot of impact stuff, they typically like it at a point stored in time, which is fundamentally different way of storing data. And while there are technologies available to do that switch, they typically never work on data sets as big as what we're going to be generating. That's been my impression. And then there also needs to be the equivalent of PCMDI for Working Group 2 or 3 and 3. Well, the thought, like I said, the thought was that that 2 and 3's needs were similar enough that you could, if you did it for the one, you could get the other. But I'm not going to make that case.
Well, you have to talk with Michael Hauptschlager and see what Hamburg is planning and whether it's going to be at all adequate for this task.
In theory, the mechanism is there at the DDC. I mean, that is the analog for Working Group 2 to PCMDI for Working Group 1.
I think that's not right. I think actually the DDC collects data, but it doesn't do the modeling comparison. It doesn't set up the experiments. It doesn't provide the tools that PCMDI provides for doing the intercomparison and the sharing of components and stuff like that. So the DDC is a start, but it is certainly not a PCMDI equivalent at this time.
Oh, no. But I mean, it has that function for Working Group 2. It may need to be worked on, but at least there's something there. It's not like there's nothing there. There's the idea that you have a data distribution for Working Group 2, taking information from Working Group 1. I mean, that was kind of the idea, and so that exists. But you may need to have, how you do that or
Right,
the
it may end
details
up
of
being
that.
a distributed system or anything.
The other thing you got is part of what he said wasn't PCMDI thing, it was a WGCM coordination role that you guys did.
No,
And that's
why
a big
we
piece
wanted.
of what's missing in Working Group 2. It's not the mechanics of the data storage and distribution. It's what the hard work you guys did with thinking about what needed to be done and what the community was to guide that, which I think is also missing from the DDC planning. And that's I don't know if there's an equivalent WGCM type thing for
Yeah, it wouldn't be
Working Group
WGC.
2 modeling or
There's
not, but that's
TJICA. I mean, TJICA is supposed to do that, right?
No, it wouldn't be them.
No.
It could be something like Ames.
Well, it's something that's going to it's going to have more of a link to one of the core projects or one of the international science programs. Because if you had TJICA doing all of that, TJICA would be playing much more of a scientific guiding role. But it'd be as if Working Group 1 was taking on the function of WGCM.
Yeah.
So you don't want to do that.
because we responded to the need, but you guys did you guys did the definition of the problem, so you do that. I don't see that happening with like the Working Group 2 stuff.
But I think the model that we've been running in Working Group 1 has worked. And so it'd be good if Working Groups 2 and 3 could find their solution to that problem.
Yeah, this is driven. I mean, this is all being driven by the community needing something to be done. So that's where WGCM has functioned, because certain things had to be done and decided, and that's where it's worked. So if there is some analogous thing that would have to happen for Working Groups 2 and 3, I don't know exactly what that would be, but it seems like there needs to be something like that.
Right. When I get the request for, we'd like you to give us, or do, something different. You're not providing what we, it really is coming from a diverse set of individuals for the most part. It's not coming from a collective state of community need. Except people say our community needs it, but that's kind of fuzzy. So the coordination of it at the international level really is important in order to get this right.
Okay, before we break up, the last point that came out of this discussion is the recommendation to stagger the working group 1 activities with working group 3 and probably 2, so that there'd be like a 2-year offset, so that you could actually do this loop in a sane way.
This was, at least working group 1 and 2 was recommended for the last go round.
Well,
It was rejected.
Richard said it's been come up, I think, the last 2 or 3 IPCCs. I can remember going way back. But it's one of those things where if we don't start the ball rolling, then it's gonna be easy for whoever says no to say no again. And so
I think it'll be interesting to hear what others say, but I'm hearing enough statements from enough people in the scientific community that they don't want to go through the recent exercise again, but they're really starting to look for something that's different. And I think that the information needs may be changing, and so that also has to be evaluated.
So that's...
And you can't have a situation where working group 2 is continually using output from 5 years ago models.
Right.
Basically.
Well, so for both that point of view for 2 and for 3, since they're going to be getting these fluxes and need time to evaluate them and come up with the new scenarios, and then also if they're going to run new EMICs to evaluate the impact of those new scenarios, that takes time. So there's a lot of good reasons to stagger them.
You could also wonder whether the split between working group 1, 2, and 3 is something you want to perpetuate
That's another issue.
About the consistency between emissions and scenarios, it is possible to have. I understand that the integration in that cycle starts from 1950 or so.
No, it would actually start 1860.
1850. Sorry.
Yeah.
And then it's possible that some of the models fails to reproduce historical emission data.
That would be another evaluation criteria for the models.
So we'll use it as a criteria for the evaluation.
Yeah. I used the analogy similarly to in the AR4, there was one model that in the picture I showed up that when in a historical run, the MOC died. That model was not then used in the evaluation for the future changes because it was deemed unreliable in the present day. I think a similar kind of evaluation will be done with these models in a historical to evaluate their future projections.
One last question. Did you say anything about resolution, model resolution?
Yeah.
No. What I've heard, what I hear from the Hadley Center when I talk to Olivier is that they're running a resolution that's had CM3.
No,
HADGEM 1. We're going to run at what we had with CM 2.1 resolution, which is 2 degree atmosphere, 1 degree ocean.
It's about the same.
So about a 2 degree class.
Yeah. The in our case, the carbon model has I noted was 3 times slower than than the physical climate model, and I just said that we were getting about a factor of 3 increase in CP time. So.
No problem.
Well, as long as you don't mind not increasing your resolution.
All right. So maybe we should kind of grind to a halt here today, and tomorrow morning we'll try to merge this all together somehow.
Everybody's exhausted.
Yeah, right. So thanks
Thank
for
you
these good discussions.